Hello, everybody. We're back with another visual pattern challenge for you. Here is our visual pattern. Here's step one, here's step two, here's step three. And your challenge is to try to predict how many boxes are going to be in step number four. And if you can, how many in step 43? In this case, I think that's going to be an awful lot of boxes in step 43. And then also, if along the way you can write an equation that could be used to express the number of boxes in any step at all. If you'd like to accept that challenge, pause the video, see how you do. All right, well, this pattern looks like it's getting big really, really fast. Step three is huge already, and step one started pretty small. So something way beyond a linear equation is going on here. That's my first intuition. What it is exactly, I don't know, except these colorings, I think, are meant to help us since this is going to be a difficult one to solve. So let's actually, instead of jumping right to making a chart with the numbers, let's look at the numbers in each of these separate colored sections by itself. So here we have 1, and here we've got 8. I'm just doing the red right now. And here, oh my goodness, what is this? 9 times 3 is 27. All right, so that's the red. In the green, we've got 2 and then 4 and then 6. And then the yellow just stays the same every time. So 1, 1, 1. Now, I think this is going to allow us to do some predictions here just by having intuition about the numbers themselves. The 1 part stays the same. So I'm going to jump right to an equation here. So the 1 part stays the same. So our equation is going to be something plus 1 on every step because we're going to add that yellow box. Now the next easiest part, I think, is this green part because it goes 2 and then 4 and then 6. So I know it's going to be 8 the next time, right? So in step 4, we're going to have 8 plus 1 plus some big chunk of red boxes. How can we express this mathematically? This is, well, in step 1 and there's 2, in step 2 there's 4, in step 3 there's 6. So I could just take the step number and multiply it by 2, right? 3 times 2 is 6, 2 times 2 is 4, 1 times 2 is 2. So step number is going to be x. So we'll call the green chunk 2x. Okay, so I think we've got 2/3 of this equation already set. What is going on with the red chunk? So I've got 1, and then I've got 8, and then I've got 27. And I think to get this is hard. I think to get this, you have to recognize these numbers as perfect cubes. So 1 cubed is 1, 2 cubed is 8, and 3 cubed, 3 times 3 times 3 is 27. So that seems to be what's going on here. If you don't make that connection between those numbers being perfect cubes, it's really hard to move forward with this one. Analyzing it by the total numbers is going to be really confusing. But once you see that relationship in the red part, and they've tried to lead you there by shading that in red, you can see that this is just the step number cubed. So we'll put x cubed there. And that's our equation, x cubed plus 2x plus 1. If you look at step number 1, x cubed would be 1 cubed, plus 2 times 1, plus 1. That would be 1 plus 2 plus 1, that's 4. If we did it for the second step, 2 cubed plus 2 times 2 plus 1, that's 8 plus 4 plus 1. That is going to be the number of boxes in here, so that's 13. So we've got our equation, x cubed, so y equals x cubed plus 2x plus 1. Let's use that to predict the next step. So step 4, we're going to have 4 cubed plus 2 times 4 plus 1. Now 4 cubed, 4 times 4 is 16, times 4 again is 64, plus 2 times 4 is 8, plus 1. So 64 plus 8 is going to be 72, plus 1 is going to be 73. So in step number 4, we're going to have 73 boxes. Now, step 43, the math is a little bit more difficult. We've got 43 cubed plus 2 times 43 plus that 1. That's that yellow box again. So what is 43 cubed? I'm punching that into my calculator, and I am getting 79,507. That is a big number. We wouldn't have wanted to draw this pattern out. And let's see, 2 times 43, that's 86, plus 1. And that, I think, is going to be 79,594. So how did you do on that one? Did you notice the pattern of the perfect cubes? If you did, you probably got all of this. If you didn't, I bet it was really, really difficult. Let me know how it went. See you next time.